So in economics, it is the dominant theory to explain how people make decisions is what is called rational choice theory. In rational choice theory, essentially, individuals have coherent preferences over alternatives, and they make decisions that are best given those preferences. The theory has been widely successful and has been applied in many different domains, from how investors pick stocks, to how college students decide what major to follow, to how people decide who they want to date. But over the last few decades, scholars have accumulated evidence that contradicts some aspects of this theory. And economists are beginning to replace this classical rational paradigm with a view of behavior that is grounded in psychology. So some of these psychological mechanisms that are used to explain behavior are things such as overconfidence, the fact that people think that somehow they're better than other people, or they have better information than other people, or people have non-standard preferences. For example, they don't like ambiguity. So this wider range of models has been great at increasing our understanding of people's behavior, but at the same time, they're often tailored to work in very specific domains. So it's almost as if we have an anomaly here. I pick the psychological mechanism that might explain the anomaly. Then I discover a different anomaly, and I go and find a different psychological mechanism that explains that anomaly. But the question is this the future? Is this how we proceed, or can we ever hope for unifying principles, that are things that are common across these anomalies? And by the way, when I say anomalies, I basically refer to things that are contradicting the standard rational paradigm of rational choice theory. So I don't have the answer to this question, but in the next 25 minutes or so, I'm going to discuss my research, which I have conducted over the last few years with my colleague here at UCSB, Emmanuel Vespa. And in this research, we've found certain commonality across many of these anomalies. Okay, so to be more concrete, what I will argue is that difficulty with contingent thinking underlies a large part of the anomalies uncovered in several classic economic experiments. Now, at this point, you might be wondering, what do you mean by contingent thinking? And that is something actually that is not completely settled. What is a good definition of contingent thinking? Without going into technical details, let me just use an informal definition. By contingent thinking, we usually mean reasoning about events without knowing whether or not these events are true. In fact, psychologists were the first to look at this issue of contingent thinking, and the very first experiment, or one of the very first experiments that convincingly argued that people have difficulty thinking contingently, was done by Peter Wason, a psychologist, back in the 60s. So take a look at the screen. I have 4 cards on the screen. The cards have a number on one side, and they have a color on the other side. The question is, which cards must you turn in order to test the truth of the proposition that if a card shows an even number on one face, then its opposite face is red? So think about this for a few minutes. Sorry, a few seconds, not minutes. We don't have that many minutes. So think about this question. Which card or cards must you turn to test that proposition? If you want to raise your hand and you think you have the answer, I do like this so I can see you. Anybody? Okay, you want to tell us the answer? Okay, that's correct. So the brown card and the card with an 8, that's actually the correct answer. That was very good, because only about 10 to 25% of people give the correct answer. Most people identify the 8, right? That's an even number. You want to see whether there's actually a red color on the other side. But many people say the 8 and the red card. Of course, the red card, that would be a mistake, because the proposition is about what if you have an even number on one side, make sure you have a red color on the other side. It doesn't say what if you have a red color on one side, what do you expect to have on the other side, right? It doesn't say anything about that. And the brown card, of course, because if you happen to turn the brown card and you happen to find an even number, that will basically disprove the proposition, okay? So again, we have very smart people here, but in the general population of subjects, this experiment has been replicated many times, only about 10 to 25% of people are able to give you the correct answer. So this is an experiment done by psychologists. It's closer to logic. You know, A implies B, not B implies not A. Let's go now closer to what the kind of the problems that economists are interested in. So let me give you a following example. Let me call that a jury voting example. You see why I call it that way. Suppose that you're a member of a group of 12 people who have to decide if a defendant is guilty or not guilty. Each member votes either guilty or not guilty, and we're going to require unanimity to convict the defendant. That is, the defendant is convicted only if everyone votes guilty. Oh, before I go there, let me just pause and say that this type of problem is part of a much more general environment that economists have been studying for many decades now, where we have people with different preferences and information, and the question is, how do those preferences and information get aggregated when these people have to make a decision together as a group? Okay, it's just a specific case of that. Okay. So let's continue with the example. Suppose that you examine the evidence very carefully of this case, and you conclude that the defendant should be declared not guilty. You're not completely sure, but as far as you can tell, given the evidence, you feel maybe that this defendant should be declared not guilty. Would you vote guilty or not guilty in this case? So this seems like a simple question. You might want to take 5-10 seconds to think about it. Would you vote guilty or not guilty? Let me ask you now the following question. Suppose that I gave you the additional information that all other 11 people in this group voted guilty. How would you vote then? In particular, would you vote differently? Now, if you're like many people, to the first question, would you vote guilty or not guilty, without any information, people say, I would vote not guilty because I looked at the evidence, as I told you earlier, and looked at the evidence, and as best as I can tell, this person is not guilty. But to the second question, many people say, I want to vote guilty because, fine, I judged the evidence, but it appears that 11 other people who seem pretty competent, I have no reason to think they're biased, also judge the evidence, and each of them, 11 of them, are voting guilty. So maybe I go back to the evidence, I reassess the evidence, I look at the evidence again, and now that changes my mind and say, you know what, I think given this information, I will vote to convict. Okay, so that's a typical response that you see in experiments. I'm going to tell a bit more about experiments later. That's a typical response, and I think that's very reasonable to think in that way. Of course, some people are very overconfident and say, no, I don't care what other people think. I judge the evidence better than anyone else. I don't care if 100 other people say this person is guilty. I judge the evidence to be not guilty. I know better. I have expertise. And they still say, I vote not guilty even to the second question. But the point is this. The point is that your answer to both questions should be exactly the same. There should be no differences between the two questions. Your answer should be always the same. In fact, when somebody asks, would you vote guilty or not guilty, right, you should ask yourself what you would do if it were the case that 11 other people had voted guilty. Even though you don't know if that's true, and it may not be true, you should behave in this environment as if it were the case that 11 other people had voted guilty. Right? Why? So that's something that is not very easy sometimes to see initially, but I'm going to make an effort to try to explain why that is the case. There are actually two possible contingencies in this problem that are relevant to you. Either one of the other jurors votes not guilty. In this case, the defendant walks, is declared not guilty, right? No matter what you vote, you can vote guilty or not guilty, it doesn't affect the outcome. If one other juror votes not guilty, your vote is completely irrelevant for the outcome. So what happens to this defendant? Or we're in the second contingency in which 11 other jurors vote guilty. Well, that's the only contingency in your vote, in which your vote does actually affect the fate of this defendant. So you should vote as if all other jurors will vote guilty, because that's the only case in which your vote has any impact. And you should vote in this way, even if you don't have any information about how other jurors will vote. So when I ask you how would you vote, and you give me an answer, and I tell you how would you vote if you knew 11 other people had voted guilty, you should give me the same answer. Because the first time I ask you how would you vote, you should be voting as if you were anticipating that 11 other people were voting guilty. So that's the power of contingent thinking, and that is something very subtle, as you can probably imagine. But a standard theory assumes in economics that everybody can carry out these calculations and understands contingent thinking very well, and then they derive predictions from that type of assumption. Okay? By the way, as a caveat, this is a very stylized version of a jury problem. I'm leaving lots of details out of this, so please don't take this as any advice on how you should behave if you're called upon on jury duty. In real life, juries deliberate, they exchange information, and many other things going on. Again, this is just a metaphor to explain the power of contingent thinking in group decision making. Let me give you another example. This example is about internet auctions. So eBay, and I've talked to students recently, and some of them ask me, what is eBay? But in my days, it was very common for younger people, when I was younger, to go on eBay, sell things, buy things, and so on. eBay, one of the major internet sites for auctions, when you bid, they give you the option to submit your bid as what is called a proxy bid. And then the system bids on your behalf up to your submitted bid. In fact, that's a quote from the website itself. They call it automatic bidding. And they say automatic bidding is the easiest way to bid on an eBay auction. Simply enter the highest price you're willing to pay for an item, and we do the rest. And that's very convenient because you may know that these auctions sometimes take several days, right? And you don't want to be paying attention all the time what's happening to the standing price. So you just submit your highest willingness to pay, and then a few days later you are alerted if you are the winner of the auction or not. Okay. So what is the logic behind the advice that eBay gives people to enter the highest price you're willing to pay? And does this make sense? Is this good advice or not? Okay, let's use the power of contingent thinking to think about this. But before that, let's simplify the situation. Let's not think of eBay. eBay is kind of complicated. It's dynamic, many things going on at the same time, many objects being sold simultaneously. Let's just think of one object being sold. And let's think of a sealed bid second price auction. You may be more familiar with a sealed bid first price auction. A sealed bid second price auction is very similar to that. So what is it? It's an auction in which every bidder submits their bid in a sealed envelope, or they submit it to a computer. Okay? The highest bid wins, as you might expect, but the winner doesn't pay its bid. The winner pays the second highest bid. Okay, that's why it's called a second price auction. Okay, these are the simple rules of a second price auction. Why am I looking at a second price auction to talk about eBay? Because if you think about this, if all of us participate in eBay and we use the proxy mechanism, we actually submit our proxy bid, it is as if we're basically participating in a second price auction, right? Because essentially the highest bid is going to win, but you don't pay your bid, you pay the second highest. eBay doesn't make you pay your bid, it makes you pay the second highest bid, the highest bid of the competitors. Okay, so it's just like a second price auction. Okay, so let's think now about bidding behavior in a second price auction. So suppose you're bidding on a used TV, and your highest willingness to pay, we'll call that your valuation. In economics, usually we call the highest willingness to pay your valuation, is $100 for this used TV. Okay? Let's compare bidding $100, your valuation, to $130, that is above your valuation, right? eBay says you should bid 100, right? You should not bid more or less. Well, let's see what would happen if you bid more than 100, say 130. For some people, bidding more than your value is appealing. Why? Well, you bid higher, you have a higher chance of winning the object, right? Who doesn't like a higher chance of winning the object? That's great. Now you may say, well, but that's risky because you bid higher, you have a higher chance of winning the object, but then you might be paying above your value of 100, right? And that's not good. But it could also be that you end up paying less than the highest value, your highest value of 100, right? You pay the second highest bid, and in particular, it might turn out to be less than $100. So perhaps it's worth taking a risk and bidding a bit more over your valuation, just because you don't pay your bid, you pay the second highest bid, okay? That's how the argument goes by some people. So let's examine this argument in more detail through the power of contingent thinking. There are actually 3 relevant contingencies in this problem. We had 2 before in the jury problem. Here we have 3 relevant contingencies. Contingency number 1. Suppose that the other's highest bid turns out to be lower than 100. Then whether you bid 100 or 130 doesn't matter. The outcome is the same. You get the TV because you're the highest bid, and you pay the second highest bid, which is a number that is below 100. You're happy. Okay. The second contingency says the other's highest bid is higher than 130. Okay, in that case, similarly, whether you bid 100 or 130, doesn't matter, right? Because in both cases, you're outbid. The highest other bid is above 130. So in both cases, 100 or bidding 130, you do not get the TV. Okay, so far, doesn't matter. The last contingency, that's a relevant one. Okay, that's like the one where 11 other people have voted guilty, and your vote determines whether the defendant walks or doesn't walk. Okay, so the last one says the other's highest bid is between 100 and 130. In this case, if you bid 100, you don't get the TV. Okay, if you bid 130, you do get the TV. You're the highest bid, but you pay a number between 100 and 130. That number is higher than your value. You don't like that. So in that case, clearly you prefer to not get the TV, right, and bid 100 than to overbid and bid 130. So in the only contingency in which bidding 100 or 130 makes a difference, you actually want to go ahead and bid your valuation of 100. Okay? Your bid only matters in the third contingency. In that case, bidding above your valuation is a bad idea. A very similar argument that I'm going to skip shows that you should not bid below your valuation. You can do that after you exit here, and see that it's exactly the same kind of argument. So eBay was right, in a way, by saying that you should bid your valuation. Now, caveat, this is only true if everyone submits a proxy bid. If you're familiar with eBay, you know something about sniping, which is basically introducing last-minute bids and so on and so forth. Well, that's because not everybody is using the proxy bidding mechanism. Okay, so again, the advice holds as long as everybody uses the proxy bidding mechanism. So that's another example of contingent thinking that is very similar to the jury problem. Now, the explanations that you hear in the literature are kind of different. In the jury problem, people say, somebody wants to vote not guilty, not because they don't condition on the event that everybody else has voted guilty, but because they're very overconfident when they read the evidence. And they believe that no matter what, what their reading of the evidence is the right reading. And then in the eBay example, in the auction example, people say, well, you know why people overbid? People overbid because they like to win. Winning is fun. I like to win stuff. I just overbid. I don't care, that I lose money, if I pay above my valuation. Right. So with Emmanuel Vespa, we ran experiments both at NYU and UCSB. So maybe I can't really see you because of the lights, but maybe I have some students here in the audience that participated in some of these experiments, where we presented them with a simplified version of the jury problem and a simplified version of the auction problem. And we found that many of the students give different answers to the two questions: how would you vote or bid in this problem? And the question, how would you vote or bid in the event in which your vote or bid matters? That is, in the event in which your vote decides the election, or in the case in which, the last contingency that I described in the auction problem. Okay? So it's not really that people are overconfident about their ability to judge the evidence, as in the jury problem, or have a preference for just winning the auction and they're happy to overbid. No, they don't overbid when they understand the problem and we help them to think contingently. It's really a problem that people have trouble with this idea of contingent thinking. Okay, one more example. So this is one of the most famous paradoxes in economics by economist Daniel Ellsberg. He's famous for many other interesting reasons, if you look him up. Daniel Ellsberg came up with a paradox as a critique to the standard rational theory of the time, and it's a pretty interesting example. So he came up with this example in the 1960s. So the example is the following. Suppose you have a jar with 90 balls. 30 balls are red, and the other 60 balls are yellow or blue. But you don't know the exact composition between yellow and blue. Perhaps 60 of them are yellow and there are no blue balls, or 60 of them are blue and there are no yellow balls, or anything between 30 and 30, 10, 50, 50, 10, any composition between yellow or blue that add up to 60. Okay. We're going to draw one ball randomly from this jar, and without observing the ball, you will have to choose between two options. Option number one, if the ball that we draw from the jar is red or blue, so red, we pay you 100, or blue, we pay you 100. So you get $100 if the ball we draw from the jar is red or blue, but if the ball is yellow, we pay you nothing. That's your option number one. Option number two, if the ball we draw from the jar is yellow or blue, we pay you $100, but if it's red, we pay you nothing. Okay, that's the second option. So take a few seconds to think about what option you would pick if you were offered these two options. Okay, just a few seconds to pick. Okay, so now I'm going to give you another question. So remember which option you picked. I'm going to give you question number 2. So in option 1, if you pick option 1 for question number 2, again, you have to pick between question 1 and 2. By the way, the ball that we drew from the first question, we replace it and put it in the jar. So it's the same jar, the same composition, the same problem. We haven't changed the jar in any way, and we have replaced that ball that we drew for question number 1. Okay? So for question number 2, you again have to choose between two options, but these are slightly different options. Option number 1 pays you $100 if the ball is red, and nothing if the ball is yellow or blue. Option number 2 pays you $100 if the ball is yellow, and nothing if the ball is red or blue. So again, take a few seconds to think what option you would pick. Okay, so remember your choice. Remember your choice. So let me now tell you what is the most typical choice that we observe when we run this experiment, right, in the laboratory. The typical answers are in bold. So for question 1, typically people tend to choose option 2. And for question 2, people typically tend to choose option 1. And that is exactly what Daniel Ellsberg noticed in the 60s. And this is a paradox. This is a major anomaly and a major blow to almost any standard theory that you can think of. Why is that? Okay, let's go to question 1 first. You pick option 2 here. That means you get the price of $100 for 60 out of the 90 balls. What about option 1? Well, for option 1, you get the price for 30 balls plus the number of blue balls. So basically, choosing option 2 is consistent with your belief that there are less than 30 blue balls. Because if you thought there were more than 30 blue balls, you would go for option 1, not option 2. So picking option 2 here is consistent with your belief that we have less than 30 blue balls, which means that you believe there are more than 30 yellow balls. So more than 30 yellow balls, option 2. Okay. Let's now move to question number 2. For question number 2, most people pick option 1. So option 1, well, you get 100 for 30 out of 90 balls. For option 2, you get 100 for, I don't know, it could be 0 balls all the way to 60 balls. I don't know how many, right? So for you to prefer option 1 to option 2 is because you believe there are less than 30 yellow balls, right? So option 2 presumes that you think there are less than 30 yellow balls. Now, of course, what is it? Either you believe there are more than 30 yellow balls, or you believe there are less than 30 yellow balls, but you cannot believe both. That's why these choices are inconsistent with any belief about how many yellow and blue balls do you think there are in the jar, given that we told you it's the same jar, we're not changing the jar. Okay. Let me skip the question of indifference. It's a subtlety I can maybe handle in the Q&A, because maybe you believe there are exactly 30 yellow balls and 30 blue balls, and then you're indifferent about everything, right? But let me skip that for the moment. Okay. Now, how does current theory explain and research explain this anomaly? They say, well, we have to revise our thinking of what preferences are. And they came up with this notion of ambiguity-averse preferences. What are ambiguity-averse preferences? They say, look, I can easily explain why people make these choices. For question number 1, option 2, you get the price with probability 2/3. But for option number 1, you get the price with probability that can be anywhere from 1/3 to 1. I don't know what it is. I'm a kind of a worst case scenario type of person, so I'm very pessimistic, so I go for option number 2, which I know it's a guaranteed price of 100, probability 2/3. Okay. And for question 2, notice that option 1 guarantees the price probability 1/3. Well, if you pick option 2, the probability of getting the price can be anywhere from 0 to 2/3. Again, if I'm a worst scenario type of person, I am pessimistic, I say, you know what, I'm going to go for option 1. That is, I don't like ambiguity, I go for kind of the things that I know what the probabilities are, and that explains how people choose. But with Emmanuel, we said, well, there's something about this problem that reminds me of the things we have learned in the auction, in the jury context, and so on, and in many other contexts that I haven't had time to describe. And what is that? Suppose that we draw a blue ball. Look at this. Your action in this case, between option 1 and 2, doesn't matter. You're going to get $100 no matter what you pick, right? Notice that under this contingency. So this is just like the contingency where at least one other member of the jury decides to vote not guilty. And no matter what you do, the defendant walks. Okay? Your action doesn't matter. Okay? And for question 2, similarly, if the ball is blue, your action doesn't matter. So your action only matters in the event red and yellow. Again, red and yellow is now here like the event in which 11 other jurors have voted guilty. So that's your action does matter. And in that case, notice that if you look only at red and yellow, option 1 gives you 100 and 0. Option 1 here gives you 100 and 0. And option 2 gives you 0, 100, and here 0, 100. They're the same options. There's no differences between these options, essentially. Okay, so we say maybe if we help and facilitate contingent thinking, maybe people will not make these inconsistent choices. Maybe it's not about their preference for against ambiguity. They don't like ambiguity. Maybe it's just about the failure to think contingently. So we ran an experiment, again with Manuel Vespa, here at UCSB. The experiment was run here at UCSB. And we did a contingent framing of the Ellsberg experiment, where we emphasized that if the ball drawn from the jar is blue, then the payment does not depend on one's choice. So this is, again, like the event in which your vote does not matter in the jury example. And then we compared the level of inconsistency between the standard experiment in the standard framing and the experiment in our framing when we help people think contingently. And in the standard framing, we get that about 50% of people give you inconsistent choices between these two questions. They give you different answers to these two questions, 1 and 2. But when we do the contingent framing, that goes down to 25% of people. So a significant reduction in the extent to which people give these inconsistent choices. So our approach with Emmanuel Vespa is to look for common sources that underlie a wide range of anomalies, as opposed to doing a case-by-case analysis of anomalies and appealing to different psychological mechanisms to explain different anomalies. And the main finding is that difficulty with contingent thinking underlies a large part of the mistakes and anomalies uncovered in several classic economic experiments. Is it preferences? Is it mistakes? We care about this question, and we can go over that in the Q&A. But what our findings suggest is that cognitive limitations may be partly responsible for many of the documented anomalies that we see in these classic economic environments. So here you have a list of references if you want to continue reading about this topic, and I'll be very happy to answer your questions.